In question A, part 2, we're dealing with an arithmetic sequence. We can tell because we've got a plus sign in this little formula area. But since we're talking about a sigma, we know we're talking about a series. So because an arithmetic series has its own pattern, it's not like the first one where it's an infinite, nor is it like the first one because it's not geometric. We know it's going to have its own set of problems to worry about. Now, there are a couple of different ways you could solve this. One way you could do it is by plugging in all of the values of n, starting with 1, which according to sigma is the starting value, and ending with 7, since sigma is designed to show us on the bottom which term number it wants us to start the formula with, and at the top tells us which formula we want to end the series with. So again, it's up to you, but plugging in is one of the strategies we can use. Another option is to use a formula. So I'm going to show you both of those options in hopes that one of them makes a little bit more sense that you could actually use. In the plugging in option, what we're simply going to do is start with n equals 1 and plug it into the formula that's part of the sigma that's given to us. So if I plug in 1 for n, that would give me 3 times 1, which is 3, minus 4, which would be negative 1. Then I'll continue doing that for all the n's from 1 to 7. So since I plugged in 1, the next logical step would be plug in 2. 3 times 2 is 6, minus 4 is positive 2. Now I'm going to keep going. Now I'll plug in n is 3. 3 times 3 is 9, minus 4 is 5. Then I'll plug in n is 4. That means 3 times 4 is 12, minus 4 is 8. Then I'll plug in n is 5. That's 3 times 5 is 15, minus 4 is 11. Then I'll plug in n is 6. 3 times 6 is 18, minus 4 is 14. Then I'll plug in 7. 3 times 7 is 21, minus 4 is 17. Now, technically, sigma tells us to stop after the 7th term, so I'm done plugging things in. But now I've got this whole series of numbers, which now simply means I need to add them up. Generally, at this point, this is a calculator issue. So using your calculator, you can plug in negative 1 plus 2 plus 5 plus 8 plus 11 plus 14 plus 17, and you end up getting your sum, which should be 56. Now, a good way to make sure that we did this properly, even though we know that we added up the numbers correctly, is to double check that using the formula for an arithmetic sequence. Technically, this is the formula for a finite arithmetic. It's finite because it starts at term 1 and it stops at term 7. It's not like what we had in part 1 where it was an infinite series of numbers that went on forever. So the formula for a finite arithmetic, and this is a little bit less formal than the first one, is to take the first term plus the last term and to multiply that sum by the number of terms in the series divided by 2. If you remember what we talked about in class, that's due to that Gaussian method of thinking about the numbers all rolled out and then folded back on one another. That terms is like the pairs. So in this particular series, the first is when we have n equals 1. So again, going back and plugging in 1 would give us, again, 3 times 1 minus 4, which is negative 1, plus, again, the last term would be when n is 7. So 3 times 7, 21, minus 4 is 17. Now, if we go back to sigma, the number of terms between 1 and 7 would be 7 terms divided by 2. So if we put this in, we have negative 1 times 17 would be 16. We have 7 divided by 2 would be 3.5, or you could just enter it into your calculator as 7 over 2. And sure enough, if we have 16 times 3.5, we do indeed end up with 56. So 56 is our sum no matter what. But again, you have 2 different ways you could have done this problem. You could have just plugged in all the values on sigma from 1 to 7 and added them all up. Or you could use the finite arithmetic formula, which is the first plus last times the number of terms divided by 2. Those both work the same way. You get the same answer. It's probably just personal preference as to which way you'd want to solve.